Welcome! Today we will take a look at the world of networks and the eternal question, wired or wireless?
Exactly. Let's look at the materials that focus on wireless technologies, such as sensors or lights, and also on choosing the right network architecture. IQRF is mentioned there, for example.
The goal is to explore which is more suitable in different situations, what the advantages and disadvantages are, and to look at this in practice. So let's get started. Where does wireless really excel? People often talk about flexibility, right?
Yes, that's probably the first thing that comes to mind. Take, for example, a building where we need to place various sensors to measure temperature, humidity, and perhaps air quality in different locations, maybe even additionally. The idea of running a cable to each sensor is, well, logistically quite challenging.
Yes, it is.
Wireless technology simply makes it much easier. We can place the sensor wherever we need it.
And something similar probably applies to smart lighting. There, you don't need a data cable for each light bulb.
Exactly. Whether in an office or even on the street, in public lighting,
It's the outdoor use that caught my attention.
it allows for much more efficient lighting control without major construction work.
This is where it starts to get interesting. It seems that a lot depends on whether we are building something new or improving something old.
Yes, and what's fascinating here is precisely this difference. In renovations or when retrofitting older buildings, wireless is often the obvious choice.
Because you don't have to cut into the walls.
Exactly. No cutting, no moldings. It doesn't disrupt operations as much. It's simply a less invasive and often cheaper solution.
Okay, what about new buildings? There, the cabling is probably planned from the beginning, right?
Mostly yes. Structured cabling is often planned right from the start for new projects. It's an opportunity to build a robust wired network.
Which will probably offer a more stable connection and higher speeds.
Potentially yes, especially for backbone connections or where guaranteed performance is required. Although even here, wired backbone and wireless end elements are often combined today.
That makes sense. But there's still the question of reliability. Isn't wireless more susceptible to interference, for example in industry or densely built-up areas?
That's a perfectly legitimate concern. Historically, that was certainly the case, but technologies are advancing rapidly. Take IQRF, for example, which is a wireless standard designed specifically for reliable communication with very low power consumption. It is widely used in building automation, industry, and smart cities. It operates in the sub-gigahertz band, which penetrates obstacles better than conventional Wi-Fi at 2.4 or 5 gigahertz.
And what about the topology? It seems that IQRF can do both star and mesh, and that it is particularly strong in mesh. What does that mean?
Well, the topology, the way the devices are connected, fundamentally affects how the network works. Star topology is classic. Everything communicates with one central point.
And if it goes down?
That's the problem. If a device is out of range of the center, it doesn't communicate either. Mesh works differently. Devices can communicate not only with the central point, but also with each other. They act like small relay stations.
So they pass the signal on.
Exactly. When a direct path to the gateway is not available, for example due to an obstacle or distance, the data finds another path through neighboring nodes.
And that increases reliability. Let's summarize the main points for deciding between wired and wireless.
In a nutshell, wireless provides enormous flexibility, especially for end devices such as sensors. It simplifies installation, which is great, especially in finished buildings or even outdoors, for example in lighting.
Sure.
Wired networks are still the standard for new buildings, where we seek maximum speed and stability. Modern wireless technologies such as IQRF, thanks to its mesh topology, can now offer truly high reliability. This eliminates some of the old disadvantages of wireless.
I understand.
And that raises an important question. How will the choice of wired or wireless, and in addition, a specific architecture such as mesh, affect not only the initial costs and flexibility of installation, but also, in the long term, what data we can collect and how effectively we can manage the entire environment, whether it is a single room or the infrastructure of an entire city district. This is actually a strategic decision with quite far-reaching consequences.
That's an interesting perspective. Thank you for joining us today for a look at the world of wired and wireless networks.